Hello and welcome everyone. Thank you for attending our webinar today titled Pion Inc. introduces B International High Pressure Homogenizers. Today we will be discussing B's patented modular homogenization technology and the benefits it offers scientists, researchers, and product developers through an innovative and highly advanced process. High pressure homogenization is a mechanical process typically used to reduce particle size, lyse cells, or create stable, uniform mixtures commonly employed in the pharmaceutical, biotech, chemical, and food and beverage industries, amongst many others. B International has been a worldwide leader in high pressure homogenization for nearly 30 years. B International, we turn pressure into possibilities. B stands for Best Emulsifying Equipment. B International are manufacturers of high-pressure homogenization technology. B was established in 1994 in cooperation with Pion Israel Institute of Technology. B moved operations to the US in 1998 and has been part of Pion since December 20th, 2022. Today, B International has representation and equipment installations worldwide. Common applications for B International's high-pressure homogenizers include particle size reduction, cell lysis, micro and nanoemulsions, dispersions and suspensions, liposomal nanoencapsulation, deagglomeration, and exfoliation. Industries that B International currently serves include pharmaceutical, biotech, cannabis, chemical, including graphene, carbon nanotubes, and other 2D material processing, beverage, food, and cosmetics. Where does B's technology fit in the processing industry? On this graphic, we see a number of pieces of equipment used for particle size reduction or emulsion and dispersion processing, and the limitations they have on particle size reduction. B high-pressure homogenizers are capable of producing micro and nanoemulsions efficiently and effectively, and have produced formulations as small as 20 nanometers. Advantage of B homogenizers. B processing technology is modular and flexible, not fixed. This allows you to optimize the equipment for your product, not the other way around, which can lead to better results in fewer passes. B systems are designed to withstand higher operating pressure, with normal working pressures up to 45,000 psi. More constant operating pressure leads to reduced variation in process and a tighter distribution of results. B homogenizers are the only systems to lengthen or shorten process duration, which can help you achieve results in fewer passes. Standard B systems have multiple processing setups. There is no need to buy additional assemblies or chambers for added experimentation. The modular design makes it easy to change small parts and wear items. Easy maintenance leads to lower long-term ownership costs. What sets B products apart? The modular technology and the experimentation that provides. In this graphic, we see one of B's patented modular emulsifying cells, where the forces of homogenization occur. Our technology offers a variety of experimentation within this cell, including flow coupling options, nozzle options, absorption cell options, and numerous flow patterns. Each of these will be covered in more detail on subsequent slides. Experimentation to optimize process. A major advantage of B's equipment is the experimentation offered with the modularity. Every product has unique characteristics, and each company looking to process a product has different requirements for the results that they are looking for. For each product, there's an optimal mixing process which accomplishes efficient processing with maximum results. B's technology offers the developer the ability to adjust a wide variety of parameters which affect the mixing process. Through experimentation with these parameters, Process optimization can be developed for your specific application. That the emulsifying cell, B offers multiple flow patterns known as reverse flow, parallel flow, and dual feed flow. Standard experimentation options include process pressure range of 10,000 to 45,000 psi, heat exchangers to control product temperature, back pressure, reactor size, and reactor quantity. One R&D formulation can produce up to 30 individual results by varying process parameters. This allows you to experiment with options to produce the most efficient process with fewer passes. The emulsifying cell, or EC for short, is part of B's patented homogenization technology. There are three mixing forces that all high-pressure homogenizers utilize: shear, impact, and cavitation. B systems are the only homogenizers that offer control over each of these mixing forces. The modularity in the cell gives you the ability to custom tailor each mixing force and optimize results for various applications. This enables various processing configurations and provides versatility for companies with multiple product lines. What is shear? Shear is defined as the relative motion between adjacent layers of moving liquids that cause tearing between particles in order to achieve particle size reduction. At 45,000 psi, fluid velocity can reach up to 900 meters per second. The forces generated are much higher than is achievable with alternative technology such as high shear mixers or other homogenizers. Shear is generated as product enters the emulsifying cell at one end, travels the length of the cell, impacts a plug installed at the end of the cell, reverses direction, and travels back through the process cell where it contacts the primary jet stream, still exiting the nozzle. These two competing streams create direct particle-on-particle shear. What is impact? Impact is a high force or shock applied over a short time period when two or more bodies collide. On B systems, impact forces are generated by product colliding with particles in opposing streams within the emulsifying cell. Impact forces can be increased or decreased depending on the EC setup. In the graphic, we see the high pressure product flow impacting the plug on the end of the emulsifying cell in reverse flow. The impact force found on B's equipment is similar to bead mills, but again with much greater energy. Cavitation. Cavitation is the formation of vapor bubbles within a liquid at low pressure regions that occur in places where the liquid has been accelerated to high velocities. The rapid expansion and subsequent collapse of these vapor bubbles create shock waves that in turn reduce particle size. On B systems, the amount of cavitation employed can be fine-tuned by varying operating pressures and back pressure controls. In the graphic, we see a representation of the nozzle orifice found on all B equipment. The nozzle is the restriction on the system that generates high pressure. Product is moving left to right on this graphic. As the product exits the nozzle, that high pressure is lost and an increase in velocity is found. This is where cavitation primarily occurs. Cavitation found on B equipment is similar to ultrasonic mixers, but with much greater energy. Here we have a graphic showing the B technology and the multiple mixing forces that we offer. There is turbulent mixing upstream of the nozzle, like an agitator. There is cavitation, like sonic mixing. There are multiple passes of higher shear than high shear mixers offer. And there is impact force, like bead mills. Each of these forces can be controlled and defined depending on the flow pattern. Technology offers pre-mixing before the nozzle to help prevent nozzle clogs. There are premixing couplings that can be chosen based on need. The turbulent flow coupling is ideal for products with a larger starting particle size or semi-solids throughout. The laminar flow coupling would be ideal for a product with a more stable pre-emulsion. Either coupling is available and can be chosen and changed depending on need. An experimentation options offered on all B equipment is the ability to change the flow pattern through the emulsifying cell. The flow pattern, referred to as reverse flow, utilizes shear and impact as the mixing forces. Reverse flow uses product on product shear versus product on equipment, which leads to less wear on the equipment itself. It has a longer process duration and is a higher energy flow pattern. Looking at the graphic on the right side of the screen, we see a cross-section of an emulsifying cell set up in reverse flow. The product initially moves left to right through the processing nozzle. The product will exit the nozzle as a high-velocity fluid jet. The energy created by that jet is captured by directing the jet stream inside the reactors and seals installed inside the emulsifying cell. The reactors and seals are represented in yellow on the cross-section. The jet stream travels down the reactors and seals, where it experiences the mixing forces of shear and cavitation. The jet stream will impact the plug on the right side of the cell, where the main impact force is felt. It's referred to as reverse flow because this jet stream reverses direction and starts traveling right to left back up the emulsifying cell inside the reactors and seals. As it does this, it contacts the primary jet stream, still exiting the nozzle. These competing streams will collide, leading to direct product-on-product shear, and the product will effectively shear itself. The exit for reverse flow is down at the bottom of the cell, so the longer process duration is defined by the product that will pass through each reactor twice as it travels down and back up the emulsifying cell. Reverse flow is an ideal flow pattern for hard or abrasive materials, cell rupture, or any materials that respond well to high shear mixers. Another flow pattern offered on all B equipment is referred to as parallel flow. Parallel flow utilizes cavitation as the main mixing force. Parallel flow has less shear, less impact, more laminar flow, and actually has a shorter process duration. So it's a bit of a lower energy flow pattern. Looking back at the cross section of our emulsifying cell, we see the outlet has been flipped with the plug, where it was previously set up on the right side of the cell in reverse. That now becomes the outlet for parallel flow. For the flow pattern here, product is moving only left to right, passes through the nozzle. The high velocity jet stream created by the nozzle is again directed inside the reactors and seals, represented in yellow on this cross section. Inside the reactors and seals, the product will experience forces of cavitation and shear, and the product will exit right at the end of the cell. So it does have a shorter process. It's got greater cavitation in this flow pattern. This flow pattern can be ideal for cell disruption, food and beverage processing, or 2D materials, carbon nanotubes, graphene. Any material that responds well to ultrasonic mixing would be ideal for parallel flow setup. An alternative flow pattern is referred to as dual feed flow. Dual feed flow allows you to add a second material after the nozzle and is unique to B International's equipment. So the patented emulsifying cell technology gives you access to a venturi created by the high velocity jet stream after the nozzle. This is ideal for extremely viscous or abrasive materials, for material with larger particles that may clog the nozzle, or materials that have to be preheated to extremely high temperatures to allow them to flow. All of B's equipment comes with the ability to experiment with dual feed flow. Further experimentation options include process duration control, varying nozzle types and sizes, temperature control, and back pressure control. Controlling process duration. Finding sufficient time for surface agents to react with the product is essential for producing stable emulsions or dispersions. On the other hand, overprocessing can occur. Having the ability to control the process duration makes B equipment effective for a variety of products. Due to the modular nature of the emulsifying cell, process duration can be customized to further control process parameters. Reactors immediately after the nozzle induce shear and absorb the kinetic energy of the jet stream. The reactors can be added or removed to extend or reduce the mixing duration. The reactor diameter can also be adjusted in size ranging from 0.5 millimeter to 1.75 millimeter. Nozzle types and sizes. The processing nozzle is the main restriction on the system that creates high pressures as fluid is forced through a small diameter. The product will undergo high shear as it passes through the nozzle orifice, and then cavitation due to the sudden acceleration and simultaneous sharp pressure drop. Nozzles are typically either made of zirconia or diamond. Zirconia is used for most applications, while diamond is offered for hard or abrasive products. Nozzle size can be as small as 0.004 of an inch, or roughly 100 microns in diameter. Nozzles can be as large as required depending on product characteristics. The smallest orifice can be used for low viscosity production and for operation at high pressures. A medium-sized orifice can be used for high viscosity products or for products with small solids that may clog smaller nozzles. Larger orifices can be used for very viscous products, for products with larger solids, or for operation at low pressure. Temperature control. All B systems include a product cooling heat exchanger to rapidly cool the product after processing. Optional chillers are offered. Back pressure is an option that offers further control over temperature generation during processing. Back pressure is ideal for products with low boiling points. Next, we will look at B's technology used successfully in a number of industries. Here we have a pharmaceutical industry success story. This was a pharmaceutical dispersion with extended release coating and alcohol base with Ethicel. The challenge this customer faced is they were looking for increased bioavailability and to achieve effective and controlled time release from their product, as well as extended shelf life of dispersion. Through R&D and process optimization, the solution was found to be a reverse flow setup with 11 reactors inside the emulsifying cell, 45,000 psi of operating pressure, and 1,000 psi of back pressure. The particular customer on the previous slide stated the goal of this unit operation was to create a uniform and stable emulsified product with small mean particle size diameters and narrow polydispersity indices. Examined the performance of a new commercial high-pressure valve homogenizer, Nano2B Gen 2, which has several features that provide good control over the particle size distribution of nanoemulsions. They added droplet size decrease with an increasing homogenization pressure, number of passes, back pressure, and emulsifier to oil ratio. Next, we'll look at a biotech industry success story. This particular product was cell lysis of E. coli in preparation for protein purification. The challenge this customer faced was to lyse cells with just enough force to access interior proteins without damaging them, as well as keep heat to a minimum as to not denature the cells. The solution B's technology offered was found optimized with reverse flow setup, either 6 or 11 reactors, 20,000 psi of operating pressure, and 1,000 psi of back pressure. This setup did include a heat exchanger for rapid post-process product cooling to control the temperature that the product was exposed to. This setup was found to effectively lyse the cells and to maximize yield. For example, of a biotech industry success story here is a nanostructured lipid carrier product. This particular study was done on a nano2b, which is B's lab scale product line. This customer's publication notes the study was to improve the oral bioavailability of SRL, a poorly water-soluble immunosuppressant, by encapsulating into lipid-based nanostructured lipid carriers, NLCs. SRL-loaded NLCs were prepared by a high-pressure homogenization method using the nano2b. In conclusion, the NLCs showed potential to improve the oral bioavailability of SRL. Another industry B's technology is commonly found in is the chemical industry. For this example here, we had a chemical aqueous silver flake dispersion. The challenge of this product was it was extremely viscous and very expensive material. The solution B's technology offered was found to be parallel flow setup, 6 reactors, 10,000 psi of operating pressure, and no back pressure. In the graphic on the left, you can see the silver flake dispersion prior to processing on B's equipment, and on the graphic on the right, you can see it successfully dispersed after passing through parallel flow setup. B homogenizers are commonly found in the cannabis industry to create stable products with increased bioavailability and shelf life. This particular success story was a cannabis-based oil-water emulsion that was processed on B equipment in parallel flow at 20,000 psi with 16 reactors in the emulsifying cell. The unprocessed product measured in at roughly 18 microns for the D50. After one pass through the B system, the D50 measured at roughly 250 nanometers, and 2 passes brought the D50 down to roughly 200 nanometers. Cannabis nanoemulsions typically perform ideally with an increase in bioavailability and shelf life at this particle size. Next, we have a CBD isolate-based oil-water emulsion that underwent processing on B systems at 30,000 psi in parallel flow setup for 3 passes. A shelf life study was conducted on this sample in December of 2021. The processed product measured in at 159 nanometers for the D50 in 2021. 1 year later, in December of 2022, the same formulation measured 169 nanometers for the D50 for just a 1% variation over the course of a year. These equipment offered this customer both maximum particle size reduction for increased bioavailability, as well as maximum emulsion stability. A common challenge found in the cannabis industry is that cannabinoids add bitterness to the product taste, and a common approach to mask the bitterness is to add flavors. Citrus is a common flavor added to cannabis to mask the taste, but the acidic pH can often be tough on equipment materials, causing premature wear. B International has developed a proprietary coating that protects product contact parts to avoid this wear that can be caused by low pH flavorings. This reduces manufacturing costs and increases reliability. What does B International's product line offer? B offers all scales of homogenizers, whether you're an R&D scientist working with small volumes, a product developer in pilot scale production, or a manufacturing facility with 24/7 output. B, Gen 2, is B's lab scale R&D style homogenizer. The Nano is a single cylinder unit that outputs 5 milliliters per stroke. Considered to be the most versatile benchtop homogenizer on the market, the Nano to B Gen 2 combines a variety of mixing tools into one instrument to create the most efficient and stable process possible. Takeaways for the Nano: it's ideal for small batch R&D. It offers unparalleled experimentation capabilities. It's perfect for higher education, and it is brand new with a re-engineered design to include touchscreen PLC and automatic pressure stabilization. There are two models offered of the Nano to B Gen 2, the first being the Nano to B 45-2. The maximum pressure of this model is 45,000 psi, and the flow capacity is up to 2 liters per hour. The Nano to B 45-6 Gen 2 is a maximum pressure of 45,000 psi, but a 6 liter per hour flow capacity. Next, we have the Micro to B. The Micro is a benchtop pneumatically driven homogenizer. Key takeaways for the Micro: it's ideal for bioprocessing and cell lysis applications. It does require an ancillary air compressor, the air requirement being 100 psi of clean, dry air. The Micro to B 30 has a maximum pressure of 30,000 psi, a flow capacity up to 15 liters per hour. Just like the Nano to B, the Micro to B is 100% scalable. The Mini to B is considered a perfect crossover between R&D and pilot production scale. The Mini offers unparalleled tools for formulation discovery and experimentation tools, as well as increased flow capacities for direct scalability. Key takeaways for the Mini to B: the Mini can handle small volumes as well as small batch production. The Mini offers a robust design that can accommodate viscous formulations and is 100% scalable. There are two variations of the Mini. The Mini to B 30 has a maximum pressure of 30,000 psi with a flow capacity up to 20 liters per hour. And the Mini 5 has a maximum pressure of 45,000 psi with the flow capacity range of 15 to 20 liters per hour, depending on product characteristics. For the pilot and production scale, we have the DB 2000. The 2000 is designed for constant operation and maximum process control. It offers a touchscreen PLC for easy operation and maintenance. Key takeaways from the 2000 include it's a pilot scale equipment that allows for higher flow capacities and increased levels of automation, increased data gathering capabilities. It offers a dual intensifier design that enables constant flow and pressure for a tighter distribution of results, and it comes with proven reliability and a lower long-term ownership costs. He offers multiple variations of the DB 2000, primarily with differing flow rates. One variation is referred to as the DB 2000 45-30. The maximum process pressure for this unit is 45,000 psi with a flow capacity up to 30 liters an hour. The DB 2030 or 45-60 has a maximum processing pressure of either 30,000 or 45,000, and the flow capacity for this model will be 60 liters an hour. Continuing with the DB 2000 product line, the DB 2000 25-100 offers a maximum process pressure of 25,000 psi with a flow capacity up to 100 liters per hour. The DB 2000 20-120 offers a maximum pressure of 20,000 psi with a flow capacity up to 120 liters per hour. This brings us to the DB 4000, our production manufacturing scale unit. The 4000 is scaled to meet capacity, process, and regulatory requirements and offers efficient continuous operation. Each system is custom built to meet specific customer specs. Scale up is guaranteed, so the same results achieved in our laboratory systems can be mass produced on the 4000. Key takeaways for the 4000 model: it's a large scale manufacturing equipment, can be fully customized for any specific application and parameter. It's got a Windows-based OS allowing full process plant integration, and scale up is guaranteed. For process pressure, the 4000 offers a range of 10,000 to 45,000 psi and a flow capacity of 290 liters per hour to 1,000 liters per hour, depending on customer need. Scalability of results. The core essence of B's technology is the complete control over every parameter that affects the homogenization process. This unique modularity and exclusive capacity makes scaling up easy and relatively uncomplicated. In nearly 30 years, we have never failed a client in scale up. On the screen, we see the emulsifying cell assemblies of the production scale, pilot scale, and R&D lab scale units. Many common parts are found throughout these assemblies, and the ability to control the flow pattern and homogenization forces throughout the EC are consistent with each platform. This makes the scalability of results guaranteed. It offers a number of services to drive customer success, including proof of concept lab testing, installations and trainings, preventative maintenance and service level agreements, genuine spare parts, remote and on-site troubleshooting and service support, as well as validation and documentation. The key takeaways for B homogenizers from today's webinar: that B offers unparalleled fluid processing capabilities for particle size reduction, cell disruption, creating stable nanoemulsions, suspensions, and dispersions. The modularity of the emulsifying cell leads to maximum experimentation and high efficiencies in a single pass. B offers the highest process pressure in the industry, up to 45,000 psi. The equipment leads to lower long-term ownership costs. B offers guaranteed scalability. The results achieved on the smallest R&D systems can be scaled and replicated on systems up to 1,000 liters per hour. And B offers unrivaled customer support.
So that concludes our presentation. We are going to move on to the Q&A session. We do have enough time to cover a few questions. So at this point, let me see. I have a question here for you, Matt. What is the best way to optimize a process for a novel product that does not have existing research using high pressure homogenization?
Sure. Yeah, that's a good question. So if you have a product that you're not sure how it responds to high pressure or shear or impact or cavitation, I typically recommend developing an experimentation strategy that focuses on optimizing process pressure and flow pattern. For example, run your product through the system under varying operating pressures, 20,000, 30,000, 45,000 psi in reverse flow. So reverse flow will apply shear and impact to the process. Then switch the flow pattern to parallel flow and run the same three pressures, 20,000, 30,000, 45,000. This will leave you with a test grid of 6 samples, all processed under different pressures and homogenization forces. You can then analyze these results and use that as a roadmap to further optimize your parameters with more passes or different EC setups or back pressure for the sample that produce the best results.
Okay, great. Thank you. Next question here. Does the process require a liquid carrier, or can it be run with an inert gas as the carrier for milling?
So the process does require a liquid carrier. It's processed through the system.
Okay. How is parallel flow setup different from microfluidizers? What are the advantages of homogenizers over microfluidizers?
So the modularity in the emulsifying cell is really the main advantage between B and microfluidizers. So the cell is not a black box, so you can disassemble it and change the reactors inside. So parallel flow passes through the emulsifying cell one time, and the jet stream created by the nozzle is directed at the reactors inside. The diameter and number of these reactors can change the levels of cavitation and shear that occurs inside a parallel flow setup. So the ability to hone in on the level of cavitation is unique to B systems and offers you maximum experimentation when using the emulsifying cell.
Thank you, Matt. Next question. What is the lowest liquid rate that it can handle?
I believe this is likely asking for the minimum sample size. So that would be done on the lab scale nano to B. So the minimum sample volume for the nano is 12 milliliters to output 5 milliliters per stroke. That remainder can be recovered by chasing with a buffer. The system can't be run dry. So for a 12 milliliter sample, you'll output a 5 milliliter stroke, and you can chase the remainder of that to collect the rest.
Okay, thank you. Next question. What is the minimum pressure in the 2000 and the 4000 models?
So the minimum pressure, typically you can get as low as roughly 5,000 PSI. Generally 10,000 PSI will be a good minimum working pressure to optimize flow rate. But if pressure is the main force you're looking for, 5,000 PSI can be considered the minimum.
Thank you. Can you tell me if your industrial model reaches 3,500 LPH at 600 bar?
So for the manufacturing model, the DB4000, those are all built to spec. So if there are specific requirements, it can be built to spec to meet the requirements you need. Typically, that'd be done with a full engineering scale review. But the answer is yes, that model can be built to any spec that's required.
Right. Can the carrier fluid be a solvent for EC of plant subsequent removal or drying? Hope that makes sense.
So the system can handle solvents. Typically, the compatibility with solvents is not a major concern on any of our systems. We use highly compatible seal materials. If it's a particularly aggressive solvent or the common one being acetone, we do offer alternate seal materials to accommodate better compatibility. And we're always happy to offer solutions to any product challenges that you may face. So if there's not something we currently offer, we're happy to investigate a solution for you.
Okay, so we have a customer here who's been using the Nano DB and Mini DB, and the results they've obtained have been impressive. They would like to ask, in case of CVD, are there products where it is recommended to do at least 2 passes, or can these results be obtained with a single pass?
So it's certainly dependent on your goals and whether it's your particle size goals or shelf life goals. Certainly results can be obtained in 1 pass. And if the customer's still here, I'd love to hear some of the parameters, whether using what process pressure you're using, flow pattern you're using, and if you've experimented at all with other parameters. but oftentimes results can be obtained in a single pass.
Okay, thank you, Matt. What is the highest sample viscosity that can be handled both on industrial scale and flow rates as R&D testing?
That's a good question. So there's no exact centipoise of viscosity that these systems are limited to, because there's characteristics such as particle size that do come into play. But generally speaking, our systems can work up to 70,000 centipoise. That's typically done with feed pressure or pressurized reservoirs. And the dual feed option is particularly a beneficial tool for extremely viscous samples because it does bypass the nozzle. So you don't have to worry about plugging the nozzle with high viscosity samples. And the dual feed is unique to B systems. Generally, extremely viscous samples are better handled by the mini to B model and above, so the mini, the 2000 or the 4000. But the nano to B can handle viscous samples as well.
Okay, next question. In order to get a good result, which one is most important, 45K PSI or EC setup?
Very good question. Generally, I consider the first order variables, you might say, so the variables you want to hone in on when experimenting to be process pressure, flow pattern, and number of passes. So specifically for EC setup, reverse flow and parallel flow would be considered a first order variable right along with process pressure. So I'd actually say they're both equally as important in that case. The setup for the EC in terms of reactor size or reactor quantity is likely a bit less important than process pressure and flow pattern through that emulsifying cell.
Okay. Next question. What is the maximum solid content percentage that can be operated for a nano suspension?
So that's another question that may not have an exact answer because again, things like particle size do come into play. But we have worked with, depending on the product, of course, solid content up to 70% solids. Typically that would be done with a big nozzle and feed pressure. But again, the dual feed flow is a pretty intriguing option for high solid contents because you can load the solids after the nozzle and have your fluid carrier come through the main orifice.
Okay. Does a smaller nozzle product, does a smaller nozzle give you better results?
Right. So not necessarily. So a small nozzle allows you to achieve the maximum pressure of 45,000 psi. And there's often a direct correlation between higher process pressure and smaller particle size. However, each product will have different characteristics and products may respond better to other process parameters. Some products may respond better to a mid-level pressure, 20 or 30,000. And in that case, you do not need a small nozzle to achieve optimal results for that particular product. But certainly many products respond to higher pressure, and you would need a small nozzle to achieve higher pressure to achieve your optimum results for a particular product. So having the full range of operating pressure available for experimentation allows you to maximize your R&D potential. So while it's not a one-size-fits-all pressure, I always recommend experimenting with high pressure for that reason.
Okay, we have one more question here. What kind of viscosity can I work with on the B systems?
Again, the viscosity is, there won't be an exact centipoise of viscosity answer because product characteristics certainly come into play and products vary pretty widely. But generally speaking, we can work up to 70,000 centipoise or so. That's usually done with feed pressure or a pressurized reservoir.
Okay, one more question here. How do you control temperature of product on multiple passes if you want to maintain a specific temperature of a product?
It's a good question. So all of our systems come with a product cooling heat exchanger. So the heat exchanger can be run with either tap water or a chiller, depending on your product sensitivity to heat. And we do offer things like automatic temperature control on some of our larger systems. So each pass will be cooled after the heat generation point, and it's a very efficient heat exchanger and will bring the product down to really any temperature you require. So for multiple passes, it's not indefinitely heating up, and it's a very short uncooled section between the heat generation point and the heat exchanger. So generally the very quick spike in temperature does not negatively impact products.
Okay, thank you, Matt. That's all the time we have for questions. I want to thank everyone for joining us today. Thanks again to our speaker for his contributions, and thank you all for being a great audience and sending all of your questions and making these webinar interactive. As I mentioned earlier, there will be a recording of this presentation and you will all have access to it. And I do want to encourage everyone to check Pion's website regularly for updates on new events, recordings, applications, application notes, and our new blog as well. Thanks again, everyone. Have a wonderful day. Thanks, Matt, and we'll see you soon.
Thank
And
you,
happy
everyone.
holidays to you all. Bye now.